I want to talk about listening dissonance. Listening dissonance and filtering noises, unwanted noises up through this. If you want to look at it through here or just up through here. Listening dissonance kind of starts with 3 and 4 because we're losing our capacity to inhibit noises coming up. So this is going to be gone. This little ABR table. And I want to talk about listening dissonance, though, because listening dissonance is why I want to talk about it so bad. Is it's not well understood. You probably never even heard of it, but every autistic phenotype struggles with it. I promise you. It's when sounds blend. It's a big problem. So what is this? It's just sounds blending. It's exactly what it is. So there's two things that I want to kind of get into, two kind of analogies that I think might help with this because of the inhibition, the excitation inhibition. So remember, if we draw out the seesaw analogy, right? Excitation here, inhibition here. This is the default for the autistic phenotype. High excitation, low inhibition, because of a lot of those inhibitory cells being missed in large part here and throughout the brain regions, okay? Because we're going to talk about more cortex areas with this listening dissonance, and I think you'll be able to make sense of it. So as signals come in, and we're reaching the cochlear nucleus here with from 2 to 3 in the brainstem response, and then from 3 to 4 is where it really starts to kind of blend, okay? By the time the signal reaches this brainstem area here, this superior olive right here, and the inferior, all the way up to the inferior colliculus. So from 3 to 4 and then 4 to 5 is whenever it's starting to happen. A role of these areas, the olivary, the lemniscus, and the inferior colliculus, is suppressing unwanted sounds. So how is this how does it know what it wants to pay attention to? Is a good question. Well, one thing you can think of is we're mapping this out from a beginning, but rarely, if ever, as you're navigating the social world as a living organism, is you're not going to have any noises, and then suddenly noises are just going to start. So that's something you really need to consider, okay? There's always background noises going on if you're up. Whenever it's sending signals up, new signals coming up, and the thalamus has recruited out with that thalamo-cortical pathway in the auditory cortex, the brain can kind of respond back and understand what noises are relevant, what noises are salient versus the ones that are not. So it can send signals back down to the olivary cortex, the lemniscus, and the inferior colliculus to kind of help shut off, kind of prevent these from happening. So a good way of thinking about this is, and it's good that we use green, but I'm going to think about this as water hose, okay? Plumbing has weird things here, okay? So this is the water hose, and then actually it mostly goes straight, doesn't it? See, plumbing's weird. So you have this, and then let's say you have a faucet. Okay. So you have a faucet. Okay. You want it, you can turn it on. So all through here, I want to go green. Let's just say this is water, okay? Because these are the signals coming up the brainstem. And then these kind of areas are the areas trying to filter this out, and even the cortex trying to suppress these sounds. If you have a leak here, or if you're trying to control the water flow here, but you can't, water is just going to come out uncontrollably. Okay, and this is kind of what this is with that endocochlear potential, where you have this strong electrical potential and that strong gradient just to shoot noises up. But if you don't have the inhibition could be a couple of different things. It could be the handle that turns it on and off, or maybe there's a filter. Maybe there's a special filter here. So that you don't have the unwanted things of the water, like fluoride or something, to get out. But maybe that filter's bad. You haven't changed it in a while. So now you're getting all of this fluoride and unwanted particles out in the water, because inhibition downstream is letting this in. So your filter, or maybe you even have a filter coming into your house, an extra filter, which is popular. It's pretty common now. This filter is bad. The role of inhibition here is to get rid of these red marks, which is unwanted, which is no good, okay? So if you want to think about it, the green are the go signals. So we have glutamate excitation running this way, because that's the direction of the water flow. And this is helping it. It's helping it push it along at faster rates, because that's our default. Our default is go, especially with sensation perception. But then you have inhibition, things like parvalbumin interneuron and somatostatin and basal intestinal peptides, remember, that are acting on as a disinhibition. We have these, let's say we just have parvalbumin and so forth, like this. This is kind of wanting to block. So we have inhibition here and some here. But we can't, based off of the context and the capacity of these inhibitions, we can't naturally control the output, the flow of the noises. So sometimes the autistic phenotype is overwhelmed with this water. Okay, so you could think of this as the difference between a water hose outside and a fire hydrant, maybe. The fire hydrant is a good way of thinking about autistic's ability for sensory processing. It's a fire hose of information, Carl Deiser-Roth says, in projections. Here, projections. It's a torrent of information, he calls it. And it's accurate, because there's no stop signals here. There is no stopping here. And each one of these areas here, the olivary, the lemniscus here, and then the inferior colliculus, is trying to provide a little bit of stopping. Because once it hits the thalamus, especially with this TRN that is already in a bad state, bad condition, everything is going to start to become overwhelming. So this is very similar to the ear canal. So we should have built-in inhibition, mainly up through here though, to help filter out this stuff. So we're up here, And we have a lot of noise. We have a lot of noise now coming in. It's just, okay, we'll use green. It's becoming overwhelming. We have so much to perceive here, okay? With the auditory cortex, which is here. And then if we map out, let's just draw a side view of this, okay? So we have the pons, the brainstem, kind of the cerebellum. Inferior colliculus is here, okay? It's here. That's what this is. Superior colliculus here. And then we have the thalamus. Medial geniculate, the lateral geniculate. I'm just going to make this kind of, so this is the thalamus here. Okay? Because I want to highlight the big thing with listening dissonance here. So the occipital, the parietal, the sensory motor here, the prefrontal cortex, kind of the temporal lobe, okay. So as noises start to become overwhelming, so A1 is over here, okay, it's more occipital. A1 is up here, and it's very lateral. It's very lateral. So A1's up here, and it's trying to, this is where perception happens, okay. We do not understand the noises until A1 kind of helps make sense of it. Like if you hear your favorite song and maybe it takes 1 second or 1 or 2 tones and you recognize the song versus, oh, what's that song? What is that song? You're just sitting there, just, oh, what song is that? You know, you're working here in the auditory cortex and other areas of the cortex. Remember, layers 2 and 3 in the mini columns will help you get there. But the thalamus is sending signals up to those mini columns to recruit layers 2 and 3. Because layers 2 and 3 is where your experiences live, your subjective experiences and your intelligence live. Okay, so the big thing with listening dissonance here, with recruiting the rest of this cortex, is going to be massive. To compensate this overwhelming noise coming through here into the thalamus and the auditory cortex, the brain and your sensory processing will attempt to recruit distal connections, especially the medial prefrontal cortex, which is here. The first time we mentioned this was in the Autism and Adaptive Responses episode, where we parsed out the medial prefrontal cortex, the ACC, anterior cingulate cortex, which is a subdivision here, and the anterior insula, which is about right here, very lateral, but also right here. So we have the dorsal lateral up here and the orbital prefrontal cortex right here. Orbital prefrontal cortex, medial prefrontal cortex is in the middle, and then this outside surface right here is the dorsal lateral, okay? Whenever you're trying to, before I explain the circuitry here with listening dissonance, a major role of the prefrontal cortex, if you're just going to explain it in one role, it's to shh. A neurosurgeon says this, Casey Halpern. The role of the prefrontal cortex is to quiet the rest of these subcortical areas. It's inactivating the subcortical areas. That way you can recruit adaptive responses. So with this listening dissonance and becoming this sensory overload, remember, because of this scenario right here, low inhibition, high excitation equals sensory overload. The brain is trying to recruit these more higher order functionings, this top-down control over this situation, because your ears will start to throb here or throb, and you just can't make sense of it. And you can feel yourself becoming overwhelmed. This is called signal to noise. Signal is healthy. Noise is not healthy. You want to, the whole thing we're talking about over here is quieting the noise, filtering out the noise. Okay? So, good, bad. Okay? So, these brain regions here that are for adaptive responses and top-down control are recruited, and they're heavily involved. And it doesn't matter if you're autistic or not. You can hook up, put the scalp fMRI on and measure brain waves, even in the typical. These areas will begin to heighten because it's trying to provide effort into quieting these areas right here. It's putting in effort into quieting this, and it becomes difficult, even for the typical. It's kind of compensating here. But because of the autistic phenotype being like this, there's even so much excitation here, and there's not enough parvalbumin interneuron, especially with this area right here, and the ACC, and the anterior insula. The anterior insula is paying attention to bodily states. So as you're becoming overwhelmed, your heart rate will change. And so is your breathing, your depth and rate of your breathing. And that is being fed up to the posterior insula and the anterior insula right here. And to the ACC. Remember the ACC? It's measuring conflict monitoring. It's measuring error detection. It's signaling errors are happening. I'm becoming overwhelmed. What do I need to do? I need to do something. And the anterior insula is being hijacked by the bodily states. And now the brain states are working overdrive, even in the typical. It's providing a lot of effort to clear out and free up the sensory processing, okay? It becomes so much that emotional circuits are also being recruited because of, right, the brain, or the brain states even, and the bodily states. So remember that third role of the anterior insula is evaluating the environment. So it has three main data sources: brain, body, environment. And this thing is becoming overwhelmed. And so it's hijacking. It's allowing these processes to be hijacked. So the insula is a good friend and a very powerful enemy. This depends on who's leading the way here. Remember, we talk about who's leading the way. When we're adapting, when we're responding well to the environment, areas like the dorsolateral and the medial prefrontal will lead the way. It will orchestrate the circuitry needed in these lower areas here, instead of vice versa. When we are overwhelmed, these lower areas, like the amygdala here and this ACC, become hyperactive, and they're hyperconnective. And these are emotional circuitries. It gets to the point where these are hijacked, and including here, the orbital frontal cortex is roughly 90% sensory, even though it's a so-called prefrontal cortex, okay? So the orbital frontal cortex, the amygdala, which is not our fear center. People, get rid of that. That's a bad misnomer. Fear center is all about correlates. We are past the times of this brain region equals this. The amygdala is also involved with positive things too, and motivation, not just fear. So come on. And then the anterior insula. Whenever these things are this kind of hijacked like this, and the prefrontal becomes shut off, we leave because that's the only option at that point. Is it an adaptive response? Maybe. Depends on who you ask. If you would ask, well, looking back at it, maybe not. But in real time, that is the option, because it is impossible to filter out all of this excessive noise coming up through here and overwhelming the brain, overwhelming the thalamus. And that is listening dissonance. This is a bad thing, and it's uncontrollable. This is why people will wear the noise canceling headphones now. And they're screaming kids. And they're just overwhelmed. Even adults, even like family gatherings. It's like gone. That's the option, is gone. Because you can't control it. Remember, I say in the podcast episode sometimes that 1960s Beatles, like 1967 and 1968, Beatles, Sgt. Pepper's album right here, White Album right here, they started to experiment with different noises, different instruments that make noises, and things just around the recording studio. They just started to make noise with them and blend them together at the ends of songs. And the songs would just carry on with all of this orchestrated, bizarre music blends. And that's what it sounds like. That's what it sounds like in real time whenever you're out and it's getting loud. You can't discriminate the sources of the sounds. You can't. Even if they're lower volume sounds, but they're multiple sources of sounds. That will hijack these areas as well. Because at first, you can pay attention. You can pay attention to the different sources of sounds coming in. Almost like you can follow along with different, maybe, conversations. But then, all of a sudden, it comes so fast. Let me tell you, it comes so fast. These things will just blend in, and these areas right here will just hijack you. And there's no more dorsolateral prefrontal cortex or the medial prefrontal cortex. The ACC cannot make sense of it. So you go. And this brings me to what I want to say most. It's not uncommon that the autistic phenotype, children, are overwhelmed and they leave. And they're found in bodies of water. Drowned. It's every week. Whenever the autistic phenotype is becoming like this, the worst thing you can do is talk to them. Why are you sitting there just keep talking to them? Well, what's the matter? What's the matter? What do you need? What do you need? Well, I can't even understand it. People that are involved in autism, even different types of educators or people that's trying to provide them therapy and so forth, they don't understand the autistic phenotype. I don't understand it. Listening Dissonance. This episode will be out next week, and this will just help maybe follow along with it. We didn't talk much about the auditory cortex, but I don't necessarily want to now. But that's where perceptions happen.